welcome back to the second part of our video tutorials on integrals involving rational expressions. Last time we did all of the pre-calc work, now we're going to do the actual integrals. So one of the things we have to understand is that when we're given an integral that involves a fraction, we may have some steps that we need to do before we can even get to the integration. One is divide if it's improper. So if you were given an integral such as 2x cubed minus 4x squared plus 5x over x squared minus 6x. The very first thing you have to do is, in this case, divide using long division because the degree of the top is bigger than the degree of the bottom. Once you did the division, you'd have some sort of term out front. Let's just say it's 2x. I don't know exactly what it is, but let's just say it's 2x. And then you'd have some sort of, I don't know, numerator. It might be something like 7 over, in this case, I'll factor the bottom and get x times x minus 6. And then the third step would be to find the linear factors. In other words, do the decomposition and break it down so that you have one number over x and then another number over x minus 6. Now these are all hypotheticals. This is not accurate, but just hypothetically, that's what we would do. So now I'm going to move on to the same three problems that we did in the last video, only now we're going to do the integration. So one of the things that you're going to see in this is we're going to deal with these fractions by trying to get the rational expressions into something that can be integrated using basic rules. And a lot of it is going to revolve around remembering the natural log of u and the integral of that. So if you remember, 1 over u, the integral of that, or the antiderivative of that, is the natural log of u plus c. So we're going to see that, or something like that, a lot in these problems. All right? So this first example, we actually did the decomposition of this in the last video, so I'm not going to redo it. I'm going to pause. You guys can either try it again or go back and look at the last set of notes and just write down what the decomposition was. So I hope you got the same answer as we did last time, and here it is, 2 over x plus 3 minus 1 over x minus 2. Well, I'm going to turn this into two separate integrals. 2 over the integral of 1 over x plus 3 minus the integral of 1 over x minus 2. Each of these is going to have the form of the natural log. And so I'll get 2 times the natural log of x plus 3 minus the natural log of x minus 2 plus c. Now this is a perfectly acceptable form of the answer, but you may see people write it using the laws of logarithms and say x plus 3 squared over x minus 2 plus c. Either form is correct. A lot of times you'll see the condensed form if it was a multiple choice problem. Second example is another one that we did in the last video, but again, I'm going to pause. You can either go back and redo the math or just look back at the last lesson to see what the breakdown looked like. Hopefully you got the same answer as last time, or just copied it from the last one. But again, we have our three different fractions, and we're going to use similar technique as to the last one. Break each one down separately. And each of these, again, looks like it's of the form 1 over u. Now, this is a fine version of the answer, and it's not likely that you would see it as a condensed form, but I'm going to write it anyway, just so you can see what it would look like. So again, the condensed form isn't likely to be needed, but it's accurate in case someone were to use that as a form of the answer. The final one that we're going to look at today was our final example from the last video, and this is the one that we needed to do long division first, followed up by the partial fraction decomposition. Long division is necessary because we have a higher power in the top than in the bottom. So again, I will pause, go back and look, or try it again and see if you can do the long division and then the partial fraction decomposition. After long division and the partial fraction decomposition, I'm now left with these four terms, and I'll integrate each one separately. Get x squared minus 7x plus 17 times the natural log of x plus 2 plus the natural log of x plus 1, all that plus c. And there really is not a need for me to combine any terms in this case. So I hope as you're doing these problems in the practice, you'll understand that when we're involving rational expressions, a lot of times we're going to need to break the fractions apart before we can actually do the integration.